nucleic acid. The ribo means ribose, so that ribo means is sugar, and the nucleic acid is the kind of amino acids that are connected with that sugar. And those amino acids are 4 types in the DNA. They're given the letters A, T, C, and G. There's 4 of them. A stands for adenine, T stands for thymine, C stands for cytosine, and G stands for guanine. And anyhow, these 4 amino means that it contains a nitrogen atom and a hydrogen atom. These 4 amino bases are combined with one another in pairs. And in DNA we only find that A combines with T and C combines with G. Adenine with thymine and cytosine with guanine. Only those 2 kinds of pairings occur. So these are called base pairs. Anyone? A with T is called a base pair, and C with G is another base pair. So only these 2 base pairs occur in the DNA molecule. So when they say they created 582,970 base pairs, it means that combination. And each amino acid is attached to a particular ribose or sugar, or deoxyribose. Deoxyribose is a sugar with 1 oxygen missing. That's why they call it deoxy. The oxygen has been taken out of the ribose. Ribose is a particular kind of sugar, and when you take out one of the oxygens, it's called deoxyribose. And when you attach one of these amino acid bases to the sugar, then you get this backbone structure, the DNA molecule, the basic structure. What they did is they created 500,000 base pairs approximately. So it's quite a feat actually to put all those molecules together into one long strand like that. But this is basically what they have done. Now how do they do it? That's the next thing. Molecule of such long length is part of what's called the Mycoplasma genitalium, a bacterium, particular bacterium, a very small bacterium, and they have measured its DNA to be the length that we mentioned here, 500,000 base pairs long. And so they wanted to create the DNA molecule for that particular bacterium, and they felt that if they can create the base DNA structure for that molecule, then they will have created or come one step closer to creating life. DNA molecule itself, creating a DNA molecule, is not life. It's only one part of the living organism. But anyhow, to synthesize such a big molecule, that's quite a feat for chemistry. But all it is a chemical process. It's not a creation of a life in any sense of the term. In fact, what has been found is that this particular bacterium, the M. genitalium as it is called, and the previous research they did is they took out the DNA of that bacterium and put another DNA in there. DNA from another creature they put inside that bacterium, and they found it could live quite nicely with another completely different DNA molecule. So how much the DNA molecule actually contributes to the fact that that thing is a particular bacterial living entity, it is uncertain, because they could take out that DNA molecule and replace it with another one of a completely different bacterium. They are uncertain as to how much replacing the DNA and the bacteria actually affects the life of the bacterium. How important is that DNA to the life of the bacterium? They can't say. If it can be replaced so easily without any change to the bacterium itself, the life of the bacterium, then how much is it responsible for the living force of the bacterium? They can't say. But anyhow, that's what they did. They simply replaced the DNA of the M. genitalium bacterium with another DNA that they manufacture themselves. So their real credit is just in manufacturing such a long-chain DNA molecule, not in creating life. Number 2, taking the heart out of the patient and putting in a plastic heart, an artificial heart. If they put in the artificial heart, we know that people can live, right? But it's not that they created the life was already there and the heart has just been replaced. What is a functioning heart has been replaced with a machine, but the life they have not created. The life that is going on in the body, they have not created. And no matter how many artificial hearts they create, those hearts don't produce anything living of their own. They can't put an artificial heart in a machine and expect that that machine will come alive. So it's not the heart that makes the thing alive. Life is already there. The heart is simply placed to keep the life going. That's all. See? Did they make that DNA molecule? This is the next step that gives some interesting information about what's going on as far as how the DNA molecule affects life and how life affects the DNA molecule. Then it says here that, now we go down a little bit, it says the building blocks of DNA, we mentioned already, adenine, guanine, cytosine, and thymine, are not easy chemicals to synthesize into chromosomes. Chromosomes means the DNA molecule wrapped around a protein is called a chromosome. As the strands of DNA get longer, they get increasingly brittle, making them more difficult to work with. Then, prior to the publication of this discovery, the largest synthesized DNA that they had previously made was only 32,000 base pairs compared to this 500,000 base pairs that they just made. Thus, building a synthetic version of the genome of the bacterium M. genitalium genome that has more than 500,000 base pairs presented a formidable challenge. However, the Ventnor team has expertise in many technical areas and a keen biological understanding of several species of mycoplasms. When we started this work several years ago, we knew it was going to be difficult because we were treading into unknown territory. Through dedicated teamwork, we are shown that building large genomes is now feasible and scalable so that important applications such as biofuels can be developed. So this is what they said then. Now the method for creating this genome. The process to synthesize and assemble the synthetic version of the M. genitalium chromosome began first by resequencing the native M. genitalium genome to ensure that the team was starting with an error-free sequence. After obtaining this correct version of the native genome, the team specially designed fragments of chemically synthesized DNA to build 101 cassettes of 5,000 to 7,000 base pairs of genetic code. As a measure to differentiate the synthetic genome versus the native genome, the team created watermarks in the synthetic genome. These are short, inserted or substituted sequences that encode information not typically found in nature. Other changes the team made to the synthetic genome included disrupting a gene to block infectivity. To obtain the cassettes, the Ventnor team worked primarily with the DNA synthesis company Blue Heron. So what is this saying here? So what they said is that they began first, they analyzed the genome of the bacterium that they wanted to synthesize. First take, what is the DNA that is already there in the naturally occurring bacterium? They analyzed that and got the correct order of the base pairs, the correct order of the A, T, C, and G. How they appear, what order they appear in the DNA molecule, that determines what is called the genome. What kind of letters it spells out. They put them all in a row, and they can determine how that DNA molecule, what that DNA molecule looks like, how it is put together. So their job then was to duplicate that. Because there was only 500,000, of course that's a great number also to conceive of, but anyhow, because there was only 500,000, they felt that was a reasonable target to try to synthesize. So what they did is they built what they said 101 cassettes of 5,000 to 7,000 base pairs of genetic code. So in other words, this seems like it's a repeating sequence. In a gene, a gene is made up of what they call codons, 3 codons. A codon is a combination of 3 base pairs in a sequence, one after another. In any DNA molecule, if you look at the sequence of 3 base pairs in a row, that sequence of 3 base pairs is called a codon. And I think it's 4 codons altogether will make up a gene. So that gene determines the characteristic of that particular of that particular bacterium is what's described. Is what's explaining the specific characteristic of that particular bacteria. And so what they have to do is duplicate that genetic sequence. And so they did that. They made 101 cassettes, what they call, of 5,000 to 7,000 base pairs of genetic code that were duplicating that one found in the original bacterium. And then all they had to do after doing that was to hook those cassettes together, those 100 cassettes together. And now how to hook them together? That's the next problem. So there they had to use a living entity. They call it Escherichia coli. By putting those base pairs together in the Escherichia coli, they were able to produce, manufacture through the living entity a number of those strands, because in the E. coli bacterium, it will reproduce, or what they call by RNA transcription, it will reproduce whatever DNA is put in there. Whatever those strands of DNA that are put into that bacterium, it will reproduce them by the process of life. Life has the process of reproducing itself. In molecules of inorganic nature, we don't find any kind of reproduction of molecules. But in the living organism, there's a reproduction going on. What's that?
They used life to, what you can say, duplicate the matter out of another duplicate matter.
Yes. They had to make a number. In other words, they can synthesize one strand in their laboratory, right? But to reproduce them, to make a number of them, they had to put it in a living organism so that the reproduction process could occur. They make clones of it, in other words. Otherwise, to produce one is a big chemical problem, no doubt. But to produce the many of them that are needed in making it's not that there's only one DNA molecule. There are many millions of DNA molecules inside the cell, and they are all needed to make a living organism. So they had to reproduce them, and they put it inside the E. coli to do that job. So in the laboratory they can produce one, though to produce millions of them, they have some problem. If they had to do one at a time, it would be very difficult. So they give that to the bacterium here. You do that work.
It's like again, what you can say, giving some food to a life and then reproduction and like that matter.
Something like that. But inside the cell, the bacterium knows how to reproduce. It takes one DNA molecule, and by a certain process of, well, you may have seen some pictures of that, animations, where the DNA unravels. There are two strands of DNA around like a helix, and it unravels, and some other amino acids come and attach one side of that DNA strand, and by that particular way of attaching, they form another strand of DNA. There's a whole process that goes on, chemical process that goes on like that, and so they have explained. And like that, another DNA molecule similar to the first one is created. So inside the living organism, that process can go on very quickly, very easily. So once they have the original DNA molecule, which they synthesized, then put it inside the living organism, it will take over the job of duplicating it, replicating it, they call it. And like that, they produce many, many such molecules. Anyhow, so that was the first step. They put together these 5,000 to 7,000 base pairs. Then the next step was to combine those small fragments of 5,000 to 7,000 base pairs into larger strands. So the next step was to combine four of those 5,000 sequence base pairs. It would mean about 20,000, 20 to 24,000 base pairs would be synthesized, putting four of them together. So here it says, the team devised a 5-stage assembly process where the cassettes were joined together in sub-assemblies to make larger and larger pieces that would eventually be combined to build the whole synthetic genitalium genome. In the first step, 4 cassettes were joined to create 25 sub-assemblies, each about 24,000 base pairs. These fragments were cloned into the bacterium E. coli to produce sufficient DNA for the next steps and for DNA sequence validation. So in other words, they could not validate what they had formed with just one molecule. There is no way that one molecule can be measured. That they use, which is gas chromatography or liquid chromatography, they can't use that method on a single molecule. They have to have millions of molecules for that method to work. So that's why they needed the E. coli to produce sufficient DNA for DNA validation, sequence validation. Then anyhow,
but E. coli is a bacteria.
Yes,
it's a
another
bacterium.
kind of,
It's a life form.
It's a life. Yes,
Right.
like I'm saying, in the laboratory, they can synthesize one DNA molecule. But in the living organism, there are millions of millions of DNA molecules.
Right.
So how they can't synthesize millions of DNA molecules. They can't do it. It's impossible technically. It will take them forever. So they only made one, and they took that one and put it inside a already living organism and let that organism reproduce it, or produce the one that they had. This is what they had to do, because they are not as efficient as nature's laboratory. Krishna's laboratory can do things that they can't do, you see. It can very easily make millions and millions of chemicals. Given one chemical, it can make millions out of that very easily, within a short time, whereas it would take them millions of years to do that if they tried to do it in the laboratory. Anyhow, then next step.
But the thing is,
what?
But the thing is, because life is a totally distinct element that is never to be found in the material sphere or material dimension. They couldn't they couldn't artificially build life in the material dimension.
Of course, that's the other thing. That's the other thing. But I'm just from the technical point of view. They have limitations. Even if they could, even let's say they thought that they could make life from just the laboratory. They would not succeed just simply on the technical basis that they couldn't make enough molecules in the laboratory to produce life. They couldn't combine enough molecules together to make a living. Because in the living organism, there's so many billions of chemicals. No way that any laboratory in the world can make those. And yet, very easily, nature is doing that. So, anyhow, there's another thing. But we're just trying to understand what they have done and how far away they are from actually making anything called life. That we consider life.
Very, very interesting that they call DNA the master molecules of life. They use the word life, protein, building blocks of life, master molecules of life, molecules of life. But they couldn't come up with life at all in their laboratories. They start with chemicals. They end up with chemicals.
So this is what they're doing. What's that?
Yeah.
Yes, Purushottam?
One thing, actually, Maharaj, as far as we have studied in our school books, what happens actually when there is a DNA replication is that in a strand, it actually divides into two parts. That means it divides into two strands. Then each of these strands actually generates another strand.
Well, produce another strand, yes. That's replication.
So, yes, Maharaj. No, so now, Mike, it appears from this entire thing is that what they have done is they have generated some chemicals from some, by some techniques, maybe I don't know from, but what they are saying, these cassettes and like that. And after that, developing those, chemicals, are they injecting it back to the E. coli cell? And then they are saying that they are cloning it, is something like that?
Yes, exactly.
Okay. So is the E. coli then replicating, Maharaj? Is that what you are saying?
E. coli is replicating that DNA strand, yes. What they synthesize one DNA strand in the laboratory. Then they put that into the E. coli, and it replicates that DNA so that it produces more of that same DNA that has been synthesized.
But it is still using the help of a living organism, the E. coli bacterium.
Yes.
So it's
like I said, they can't produce the DNA that is even needed to measure. To measure, they need to have a lot of DNA available. And so in order to get that measurable quantity, they have to put it inside a living organism to have it reproduce, replicate it.
Yeah.
So they put the original pattern in, then to replicate it requires the living entity to mass produce it. Anyhow, the next step, after they've combined these big 4 pieces of 5,000 base pairs into 24,000 base pairs, then they took those big pieces of 24,000 base pairs and created 8 of 72,000 base pairs. How is that? Let's see. 24 should only be 3 or 4. Oh, I see. So they added 4 more. So 4 and 4, that's 8. So the 24 came from 8. So, rather, the 24 came from 4 base pairs, combined 4 cassettes. Yeah, 4 cassettes of 5,000 base pairs would make 24,000. Approximately 5 to 7,000 base pairs would make 24,000. And then if you combine 4 of those 24,000, you'll get 72,000 base pairs. And so 4 and 4 is 8. Anyhow, the numbers are not exact, but something like that they're doing. Then these 1/8, 72,000 is 1/8 of the 500,000 they have to get to. So these 1/8 fragments of the whole genome were again cloned into E. coli for DNA production and DNA sequencing. Step 3 involved combining 2 of those fragments, 1/8 fragments, together to produce large fragments of approximately 144,000 base pairs, or 1/4 of the whole genome. So again, all by putting it in the E. coli, they were able to combine these things like that. Then at this stage, here's an interesting point, the team could not obtain half-genome clones in E. coli. In other words, they couldn't combine the 1/4 genomes into 1/2 genomes. They couldn't do that by this process that they were using with the E. coli. What they had to do is put that that 1/4 genome into a yeast cell. A yeast cell is also a living organism, and found that it was the only thing that would tolerate the large foreign DNA molecule parts, and that they were able to assemble the fragments together by homologous recombination. This process was used to assemble the last cassettes from 1/4 genome fragments to the final genome of more than 580,000 base pairs. The final chromosome was again sequenced in order to validate the complete, accurate chemical structure. So here they ran into a problem. Somehow the process they were using of combining those smaller parts into larger parts broke down. At about the 144,000 base pairs, if they tried to combine 2 of those sequences together to make a 250, approximately 250,000 string of DNA, they couldn't do it in the E. coli. They had to take those 144,000 length bases and put it into a yeast cell, and that yeast was the only thing that tolerated these synthesizing these large fragments of DNA. and they don't know why that happened. Why that is a mystery to them. Why that happened, why the E. coli could not do it, but the yeast could do it, they don't know. What is the reason for that? Have no idea. Only how by experimenting they found, okay, well this works, so we'll do it. So somehow they made something, but how they made it they really don't know. Somehow the life did it. The life of the E. coli, the life of the very insignificant yeast cell. Even the life of an insignificant yeast cell is more intelligent than these big scientists who are putting all these hundreds of thousands of molecules together. You see?
Maharaj, they could.
There's no intelligence compared to the scientists, and yet that yeast cell knew how to do what those scientists could not do.
What is interesting is that they couldn't even produce one yeast cell. They couldn't do that in the laboratory.
No.
They have to take it from the environment. Right. They have to take it from the environment.
Not only could they not produce a yeast cell, but they don't even know what the yeast cell was doing, how it did it, what they could not do, and what even the bacteria E. coli could not do. Anyhow, E. coli would seem more intelligent than the yeast cell, in fact, because E. coli moves around. Yeast cell just sits there and multiplies. But somehow the E. coli was less intelligent than the yeast cell as far as putting DNA molecules together.
Maharaj, Prabhupada is saying that, this cow, Maharaj, takes, this grass and converts it to milk. But scientists, by creating any machine, cannot do that. Life can do such, wonders, what you can say, very easily.
That's right.
Mystic.
That's right. To make their, so that nobody would misunderstand that their DNA was unnaturally occurring. That somebody could say, "Oh, they took a DNA from some other living organism and put it in there." In order to disprove anything like that happened, they actually sequenced what they call a watermark into the DNA molecule. According to the sequence of base pairs, they could spell out different words, and they found that when they originally synthesized that first DNA molecule, they looked at the sequencing that occurred on the sequencing that occurred after they had put their artificial DNA molecule in there into the M. genitalium, and they looked at the sequencing that occurred, and then they tried to look for that watermark, that code that they had put in there, and they found these different words. And what it says is the Ventnor Institute, Craig Ventnor, Ham Smith, Cynthia and Clyde, Glass and Clyde. And if you look at the inventors of that molecule, you'll find what they had put in there. They put the name of their institute, the founder of the institute, and the workers who were working on that synthesis. You see, they put their names in there. Now, people were criticizing them for doing that because they said, first of all, they were looking for something. If they were going to do something like that, you would think they would put something very, because it was quite a marvelous development, marvelous invention, they would put something profound and try to write something profound message in those DNA molecules. But what they did is they write their own names and their own institute. Now, this is the kind of mentality they have. It is our invention. We have done this. We get all the credit. Now, if you look at something like Samuel Morse, you know who Samuel Morse is? He developed the telegraph. Morse code. You heard of Morse code?
Yeah, Morse code.
He developed the telegraph. Anyhow, first telegraph he sent from, I think, from Washington to Baltimore, or something like that. And do you know the first message that he sent on the telegraph? He was thinking, what can be the first message I send? What did he say? Do you know? He gave, huh? What's that? He said, no. He gave one quote from the Bible. He said, "What hath God wrought? What hath God wrought?" Giving credit, how some amazing invention had come about. This message, this ability to transmit some kind of a message over an electric wire. To transmit a message over an electric wire. This is the first time in the history of the known history of the world that this had been done, and he wanted to have a suitable message to historicize that step. And so he gave the very nice saying, "What hath God wrought?" And this was actually a marvel of God. This was a marvelous thing of God's nature, that such things could be done. Very nice message he gave. He didn't think of it actually himself, but somebody, some lady, one daughter of some man that he knows in the train station, the train offices or something like that, came up with this, that this would be the appropriate message, and he liked it very much, and he sent that. He had asked many people what kind of message I can send as a first message. And one simple lady came up with this idea, and he liked it very much, and he sent that message.
Yeah.
So how much has changed from that time to this time? Even on the moon, who was that? Glenn, what's his name? Who walked on the moon the first time? John Glenn.
Alvin Aldrin.
Louis Armstrong. It's Louis Armstrong.
Neil Armstrong.
Neil Armstrong.
And he said, one small step for man, one giant leap for mankind when he stepped on the moon. Wasn't it? Something like that.
Yeah. Yeah.
Yes, sir. One small step.
One step plan for man. Giant leap for mankind.
One small step.
For man. He said one small step for man,
yes.
One giant leap for mankind.
For mankind.
Giant leap for mankind. And not so bad, but it's still nothing, no religious content in that. No religious content. But Mars had given her something with some recognition of God, at least. The recognition of the glory of God. But in this last thing, you can see which way the world is going. That they have praising themselves. Oh, look at what we have done. This is by us, Ventnor Institute. And we are all the people that have done it. Anyhow, and they did not give any credit to the yeast or to the E. coli, I noticed.
They couldn't understand it.
But to speak of God, they could not even give credit to the E. coli or anything. They have done now. What they want to do next is to create a, this is only the beginning of their plans. Eventually, they want to create an artificial life. And here's what they say: this is an exciting advance for our team and the field. However, we continue to work toward the ultimate goal of inserting the synthetic chromosome into a cell and booting it up to create the first synthetic organism. In other words, they want to somehow or other create life from that DNA molecule. Of course, whether DNA has anything to do with life or not is a very questionable assumption. Like I said already, they found by putting another DNA molecule, a totally different DNA molecule than is originally found in the Gentium bacterium, put another DNA molecule in there, that doesn't affect the life of that bacterium. So it doesn't seem that the life is dependent upon the type of DNA it has in it. No. Just like our life will not depend on what kind of heart we have, whether we have a plastic heart or original heart.
Yeah.
Doesn't affect the life. So the DNA doesn't seem to affect the type of life or the ability for the thing to live. At some simple level, at the simple level of that bacterium, it doesn't seem to be have much of a determining factor. So, well, I don't know how much change that bacterium could withstand as far as the DNA structure is concerned, but to a limited degree, certainly, the life of the bacterium doesn't seem to be influenced by the type of DNA it has. But whether a dead cell can be brought to life by putting a synthetic DNA molecule into it seems a very remote possibility. But this is what they want to do. Anyhow, now, I wanted to, yes, there's another quote, another article, a very interesting article on the same topic that I found. This one is expressing from, what is this from? Wired magazine. Some critique of this so-called artificial life, and he puts with a question mark, and he calls it old news. It's old news, he explains, because this is what the scientists have been saying all the time, that if you can put the molecules together in the proper way, it will have created life, and he mentions here, it will have erased one of the last mythic distinctions in science, that between living and non-living matter. So this is not what he's saying. This is what the scientists are saying, that they think that they are believing they can erase this distinction, mythic distinction, between life and non-life. That's what they call it. That's what the scientists think. So he says, I get the impression that I am supposed to be tingling, my heart racing with exultation or terror or something. And yet I feel like I have a lesion in my amygdala, unable to respond to the threat of an electric shock. In some ways this is actually old news, and in other ways it's news that hasn't yet been written and won't be for decades. In other words, what they are claiming and what has actually happened are two different things. What claims to be such a big invention to titillate everybody is actually what we have just explained is a very commonplace thing and not really anything very to get excited about. They haven't done anything, basically. So let me make it clear that I am impressed with the new work from Craig Ventnor Institute. As a technical tour de force, it really speaks for itself. It's very hard to synthesize big chunks of DNA, especially if you want them to match a desired sequence with a perfect accuracy. In the past, scientists have synthesized the tiny genomes of viruses and larger segments from the genomes of microbes. The newly synthesized genome, a copy of the genome of Mycoplasma genitalium, comes in at more than 500,000 base pairs. Ventnor's team ordered up parts of its genome from commercial DNA sequencers and then figured out how to piece them together. When they resequenced the genome, they found that it matched their original specs. Their plan is then to insert one of these artificial genomes into a DNA-free cell and see if it lives. The next step will then be to slim down Mycoplasma's genome to the bare minimum, perhaps just under 400 genes, and boot up a cell with it. At that point, the scientists will have brought to life an organism that never existed before. But what does doing this really signify? What does it teach us about life that we didn't know before? It was indeed a time when scientists believed there was something fundamentally different about living matter and non-living matter. It's called the Middle Ages. The scientific revolution helped open our eyes to the fact that living things are made of the same stuff as non-living things. By the early 1800s, it was possible for scientists to synthesize an organic molecule, urea. In the 20th century, quantum physicists wonder if life defied the laws of physics that govern the rest of the universe, but molecular biology made it clear that it didn't. So ultimately, putting together a synthetic organism would simply confirm what scientists have known for a long time. Of course, this is what generally scientists are thinking. He is speaking as what general scientists think. The challenge to the project is not conceptual but technical. If you actually read the paper in which Ventnor's team report the latest step in their project, it is supremely fiendishly technical. They have a lot more tedium to survive before they create new life, and once they figure out how to build a viable genome and get it safely into a host cell, and if the two can cooperate nicely, what else would you expect but for life to emerge? There's a lot we don't understand about life, of course, but Ventnor's project isn't going to answer all the questions. We're a long way from playing God. The scientists didn't assemble the fragments of DNA by themselves, nor did they program robots to do so. Instead, they injected the fragments into E. coli and let the bacteria do the job themselves. Eventually, it turned out that E. coli could only build up a quarter of the genome. The scientists don't quite know why, so they injected those big chunks of mycoplasma DNA into yeast. Lo and behold, the yeasts were able to finish up the job for the scientists. They don't quite know how the yeast did their own biochemical magic either. I would assume that God would have this kind of stuff figured out. But when and if Ventnor's team does create a viable synthetic life form, our ignorance will remain profound. Out of 382 genes that the scientists have identified as potentially essential, 110 of them are absolute mysteries. Scientists have almost no idea what they're for. There's nothing unusually mysterious about mycoplasma's genes. Other species have genomes loaded with genes of unknown functions. Scientists have gotten very good at manipulating genes, at copying them or using them to make biotechnology products like insulin, but they still know relatively little about how genes work together in living things. Creating a new living thing will just mean creating a new set of mysteries. To solve them, scientists will have to plod away with a vast number of experiments. Only then will they get a deeper understanding of life. If we're lucky, we'll be alive to read the headlines. Then maybe the tingle will kick in. Anyhow, it's a very nice article, very little critical, little funny, and of course, but it's based upon an understanding of what the scientists think about the similarity between life and non-life. But at the same time, he is very critical of what they have done in a very practical way, very down-to-earth way. He is criticizing what they have done as not something very great. And this is the point we wanted to make. All news. This is the point we wanted to make.
I have one observation, Maharaj.
What's that? Yes, Prabhu?
Actually, Maharaj, it is very interesting that actually this thing didn't work out in E. coli, but it worked out in yeast. So actually, Maharaj, when our Guru Maharaj met Werner Arbor, who is a Nobel laureate in I think physiology, and actually he has worked on E. coli also, and they have discovered what is known as the restriction enzymes. So these restriction enzymes, they are actually some special enzymes which defend the E. coli DNA from being attacked by external attacks. So then actually we see that in the case of E. coli, there is some kind of a defense mechanism working, or something happened that they didn't accept this kind of injection. But in the East, the same thing has been accepted. So actually, while discussing this point with Guru Maharaj, so Aro was saying that actually this is very interesting, and it seems to me that the nature has endowed the this E. coli with some kind of tools to protect itself. So then he says this mutation, what the scientists are saying, mutations is not an error, but it must be some kind of fine tuning. So he was actually in that line actually. So I think this is a very interesting question, and it has some deep philosophical also aspect. Aspects. While that why this particular E. coli didn't accept, but East has accepted. So I think this will be a very interesting question also, Maharaj.
Yes, that is one of the things they are facing with understanding exactly what that problem is, and whether they will ever figure it out, we don't know. But somehow, these things are happening by the living entity that the scientists have no idea of. Many things are going on like that. Not only in this situation. We know that even in cosmology, there are so many things they don't understand now about the universe. Just a few years before, they thought they had everything figured out. With their relativity theory, Einstein's theory, and all these advanced theories, they thought they had understood everything, and it was just a matter of, filling in the details. Now they have come up with 97% of the universe is unknown matter, dark matter. And unknown
dark matter.
Dark matter and dark energy.
Right.
So this is called fudge factor. They had to put this dark matter, dark energy, to explain some of the observations they have made. That there's not enough gravity. According to their theories, there's not enough gravity in the universe on known matter. Known matter does not produce enough gravity to hold the universe together. To the size it is, it requires a certain amount of gravity, and there's not enough matter in the universe to create that much gravity. So they had to postulate that there was some dark matter that they were not seeing in order to account for that extra gravitational force. Something like that.
Question, because I talked to this gentleman who has been a Vaishnava for like 35 years already. I was very shocked to hear from him that there is a living entity, or there is an individual soul inside an atom. And I said, I never read that from any of the books of Srila Prabhupada in the Vedas, and I've never heard or read that there is an individual, a jivatma, inside an atomic particle. From what I know, inside an atomic particle is the Paramatma, who is Krishna himself in his all-pervading manifestation. In his all-pervading manifestation as Paramatma. But an individual soul within an atom that would defy the matter by itself and matter under the influence of life concept. Because when we say that there is a living, an individual soul within an atom, then what is material energy then, and what is spiritual energy? Material energy is dead energy in a sense, but what makes it working is because of Paramatma, or Paramatma's inferior energy, which is the material energy. What can you say about that?
Yes, we have to understand what matter is. What matter is. What is matter, first of all? Atom, whether it's atom or any other kind of matter, what is matter? So Prabhupada has explained that matter is undeveloped consciousness. Consciousness that is not developed to its spiritual potency, to recognize its own spiritual nature. That is called matter. So he called it, matter is the symbol of undeveloped consciousness. He told me personally that. Prabhupada told me, I asked him, and Prabhupada told me that his symbol of matter is the symbol of undeveloped consciousness. Undeveloped consciousness means it's consciousness in a dormant state. It doesn't know what it is. Consciousness doesn't know that it's spirit. It has a connection with God. That's called matter. Now, if atom is there as matter, if we conceive the atom as a material piece of matter, as a piece of matter, and if it is matter, then it means there must be some undeveloped consciousness there. It's the only thing it can be, because that is the meaning of matter. So there's some undeveloped, now whose consciousness is undeveloped? Is it Paramatma's? Paramatma can't have undeveloped consciousness. So there must be a Jiva there. Jiva can have undeveloped consciousness. And wherever there is Paramatma, there must be Jiva. Paramatma only occurs in connection with Jiva. Otherwise, what is he para to? Para means higher Atma. So there must be a lower Atma. So Paramatma and Atma are both together all the time. So there must be a Jiva in the atom. There must be a Jiva there, but is totally covered over, totally forgetful of what it is as spiritual particle. What's that?
In Life Comes from Life book, Prabhupada says that Krishna is so energetic, he can convert, what he can say, life into matter and matter into life, because that is his energy. Maharaj?
Yes, Prakriti, Paraprakriti.
External and marginal.
Anyhow, you understand?
I'm a little. I need to. I need to pray more to Lord Paramatma. Yeah, because I never heard that. I never read that in the Srimad Bhagavatam. I never read that in all of the books written by Srila Prabhupada.
And what do you think? It's only if it's only. But think about it. If it's only Paramatman in the atom, why would Paramatman be in that atom?
Because it is stated that
where did the atom come from?
Well,
where did the atom come from? That Paramatman has to be in there. First of all, what created that atom?
For me, when I the atoms, as we know, is the ingredient of the material energy. One of the ingredients, like time, is an ingredient of material energy, and atom cannot be or cannot be produced, or cannot be destroyed, and therefore, why is that so? Because Lord Paramatma is there. But when we say that there is a dormant jivatma inside an atom, then we are saying that the stone, let's say a stone, is also a living entity in a way. But as we know, the stone is dead matter. There is no life in a stone. But the body that we have right now, although it is made of material energy, there is life in it because it's called a living organism, because there is an individual soul within a body, within a material body, like a human body, for instance, or it can be let's say a bacteria. A bacteria is matter under the influence of life, but a stone is matter by itself. Now, when we say that there is a jivatma within atoms, then where is the difference now? What may be the difference? So it's all matter under the influence of life then.
But there are different degrees of life, of consciousness, right? Human life, human form of life, the body of the human being has a consciousness that is higher than the consciousness that we find in an animal, and the consciousness in the animal is higher than we find in the plant, and the plant is higher than the consciousness we find in, I don't know, what comes lower than that, a bacterium perhaps, or a yeast cell. And like that, there are different levels of conscious expression, manifestation in matter. So this gradation of consciousness can go all the way down to what we call an atom, where consciousness is not manifest at all. Why not? Or rocks, even rocks are conscious beings, yes. There are mountains that are conscious, that are living. These are explained in the scriptures.
Yeah.
And mountains are also living. Yeah. They have a life cycle. Even the environmentalists, the ecologists know that mountains have a life cycle. So all things have life. But may be not manifest to such a great degree from one to another.
It is described in the Srimad Bhagavatam that the material world is just a fourth of the entire entire creation.
I
wouldn't want to call it
yes. No, the spiritual
world. It's just
there's only 1/4 of the spiritual world.
Right. So it means that the material world is also part of the spiritual world in the truest sense. So in the spiritual world, there's only life there. There is no matter in the material.
Consciousness is awakened in the spiritual world. Consciousness is fully awakened, and its recognition, it recognizes that it is of spiritual nature. Consciousness is the symptom of spirit, right? And so it recognizes its true origin as spirit, not that it thinks that it's coming from some conditioned state of matter. Consciousness reflects in its own self, its own nature, as spiritual, pure spiritual nature. Whereas in this conditioned world, it doesn't have that awareness of itself as spiritual. Consciousness thinks only in terms of its body. It's only conscious of its body. It was limited, the object of consciousness. That's all it's aware of. You see, consciousness is absorbed in the object of consciousness, what it is conscious of, and not recognizing where it comes from, what its own source is.
Is it safe to say then? That everything is life? There is no dead matter.
Yes, ultimately yes, because it explained in the Bhagavatam. Janmadasi yatad vayat itaritas trateshu abhigyasvarat. The original source of everything is life. The abhigya. Abhigya means who is conscious, cognitive. That is Krishna. So ultimately everything is coming from that. And whatever there is then is a transformation of that. So underneath there is consciousness, no doubt. And this material world is just a sleeping state. Mahavishnu is in Yoga Nidra. And from him is coming the material energy, from the Yoga Nidra. As a dream.
Yep. In the, if you may allow me, from Mahavishnu, Garbhuda Kasai Vishnu emanated from Mahavishnu, and Sri Kasai Vishnu further manifested in all the different living entities that is to be found in the material existence, including, he entered into everyone's heart. And it is described that he also entered into every atom. Now, I think that when we say he entered into every atom, right now the world is in such a way that everything is atomic. I mean, between me and you, between the air has atomic particles. It's everywhere. So in a sense, the all-pervading manifestation of Krishna, the Paramatma, is present is present within each and every atom. But when we say that there is a Jivatma inside an atom, that is my confusion, because if there is such a thing as an individual atma inside an atomic particle, how is it that the Paramatma entered each and every living entity then? So there is a difference now between the living entity and the atomic particle being part of the material energy, as compared to the Jivatma being a marginal energy or part of the superior energy or the internal energy of Krishna. I'm a little bit confused there.
Well, just like I was explaining, the living entity can go into very low forms of life, what we call very low forms of life, even mountains and stuff like that, or trees, where they don't seem to exhibit any symptoms of life, except that they are, birth, death, old age, and disease, but they don't show any other, kind of like a passive existence.
The tree is different. Because trees we can see the growth of a tree. There is a.
But even in an atom, however, but even in an atom now, the scientists know that there is activity. There's things happening.
It's always moving.
There's something happening there. Yes. There's not. it's not as indeterminate as we originally thought of atoms. But they find that there's a great deal going on inside an atom.
But isn't that because of the Paramatma's presence inside an atom, that it continues to have activity? I mean, even hard matter, there is a continuous vibration going on.
But then, like I'm saying, Paramatma implies that there must be Atma. Otherwise, how can we speak of Paramatma? Paramatma means who is higher than the Atma. So if Paramatma is present there, then Atma must be present there. Otherwise, we can't speak of Paramatma or the atom. Paramatma won't be where there's no Atma. Can you speak of higher? Something just higher, just by itself? There's no higher just by itself. Right? Higher means higher than something. Something must be lower than something higher. So the higher Atma is there, then there must be lower Atma too. There's no existence of higher Atmas anywhere without a lower Atma. So Paramatma doesn't exist in the spiritual world, only in the material world.
Yeah. Now, from what I read in the Srimad, there is a statement that says, I don't know exactly which part of Srimad that is, that the atomic particle is an inert matter, and therefore, right now, when I heard that gentleman, that devotee, who talked about atoms having like a type of consciousness, like a type of awareness as an individual in each and every atom. That I kind of like questioned it, because if there was such an individual Atma inside an atom, then where is the difference between matter by itself and matter under the influence of life? It could, in other words, it could just be matter. It could just be influence of life. We could not. We could not.
You see, the thing is this: why we have to understand again the definition of matter. Matter has no meaning independent of life, of consciousness. There's no meaning to matter independent of consciousness, because matter is covered consciousness. You're thinking that matter is something completely different. Consciousness is something completely different, but they're connected. There's no matter without consciousness, because matter is covered consciousness.
When you say covered consciousness, there is individual Atma there. Only it is covered.
Consciousness is covered. Undeveloped.
I know.
Consciousness. Even the modern psychologists, psychiatrists, psychologists, they think that there is something called the unconscious. And even we can see some people become unconscious. Does that mean there's no consciousness there? No, the consciousness is still there, but that is not manifesting. So matter is something like that, is the unconscious. So anyhow, these are things that we have to think about, no doubt. It's not simple, but it's there in Prabhupada's books and some of the things that he said to the devotees. It's a good thing to study these things and learn about them. This is what our business is. Atato Brahmajigyasa. We have to inquire about these things. So, Prabhus, I thank you all.
Thank you very much,
for
Maharaj.
coming today. Now it's getting a little late.
Thank you, Maharaj.
Yes.
Thank you, Maharaj.
Right, Prabhus.
All glories to Srila Bhakti Mata Puri Maharaj.
Thank you, Maharaj.
Hare Krishna.
Puri Maharaj.
Hare Krishna Maharaj. Dandot Pranam Maharaj.
Jai Srila Prabhupada ki Jai. Gaur Bhaktivinoda ki Jai.
Jai.